Good day, everyone. I'm Joe Totoni, Design Principal with Icon 5 Architects, and I'm delighted to share with you today the conceptual approach and solutions to the 75,000 square foot, three-story Gale Lemerand Student Center at Daytona State College in Daytona Beach, Florida, and how structural steel gave us the pathway to realize this concept. The architectural challenge for this project was to create a new student center that would transform the campus's physical relationship with the town of Daytona Beach and Volusia County, and express the campus as the main center of intellectual life to the community. The campus currently sits along International Speedway Boulevard, a main arterial road that connects its famed beachfront with the rest of Florida. But the campus is inward-looking to a central quad with the backs of all its buildings facing the public streets and surrounded by a sea of parking, thus disconnecting the campus from the community. And the college wished to change that expression and image with this building. So the solution was to create a threshold or portal building that embraces the public promenade from International Speedway Boulevard, that removed a portion of parking between the boulevard and the campus to create a landscape welcome lawn and drive between the boulevard and the campus, and to create open fluid pathways and portals through and around the building to welcome the community into the campus. These building pathways and portals were created with the use of structural steel. For this mostly commuter campus, the building and its siding needed to allow that passage through its center into the central portion of the campus, while at the same time presenting a new face to the community. The resolution three-dimensionally resulted in a grand central portal extending above the roof to frame the passage to the campus beyond, and a cantilevered east wing to the building that allowed passage from the parking beneath the building and to the campus quad. That cantilevered east wing and that central tower portico are framed in conventional wide flange and tube sections of structural steel. Connecting those elements together are structural steel columns and beams arranged in a radial pattern to form the sweeping embrace of the front facade that faces the community. Removing the precast glass and bronze solar rain screen enclosures reveals the structural frame that gives form to this composition. Aside from the overall conventional framing of the base of the building, there are three distinctive structural conditions that support this solution. A structural tower mast that supports the cantilevered east wing, structural steel tube framing that creates and supports the tower portico, and a steel truss that creates a large three-story opening in the center of the building that overlooks the quad. The east stair tower was designed as a structural mast that supports a truss that cantilevers over and supports the second, third, and roof framing of the building. It allows for unimpeded passage beneath it from parking to the campus quad. Steel tube framing was used to create the portal tower that gives rigidity and surface area to the form of the tower and allows us to support a bronze rain screen from it. The dynamic structural form of the portal tower is covered in an open joint bronze paneled custom rain screen system. The structural steel tube framing gave us a perfect substrate to anchor the cold form framing from which the bronze panels were hung from. Inspiration for the portal as a gateway to the campus came from many different sculptural precedents. It was the versatility, though, of the steel framing that allowed us to realize that idea, while at the same time being able to transfer lateral forces from the Floridian hurricane force winds. This is a view of the Student Center from the campus quad, and you can see the large portal opening in the precast concrete that looks into the commons. That large spanned 60-foot span is achievable with a structural steel truss, which supports the roof and canopy overhang from above. Internally, cantilevering steel allows us to create a column-free 3-story amphitheater-style commons. That commons connects all the program spaces of the Student Center together internally and overlooks the lush campus quad in the middle of campus. In addition to those major design components of the building, steel is also expressed in more refined details throughout the building, like the sculptural grand stair and skylight above it. Additionally, the support system for the exterior bronze south and west facing solar screens utilizes steel framing. We wanted to maximize views and daylighting internally to create a pleasant environment that promoted well-being. But at the same time, we needed to control the harsh Floridian sun. A bronze perforated solar screen that was supported by steel framing, which is visible through the screen from the inside and outside, allowed us to control that condition. Thank you for reviewing this project. We're delighted to present it to you. It's been a pleasure. Thank you.